Welcome everyone. I am Jansi and I am currently pursuing my BA in Sri Venkateshwara College of Engineering and I am from Basic Science Department. The subject is Mathematics for CSE stream and I am currently studying in first semester. The topic which we are going to discuss in today's video is encoding and decoding. So these are some of the topics which we are going to discuss in today's video. Introduction to encoding and decoding, process of encoding and decoding, types of encoding and decoding, applications of encoding and decoding in various mathematics and engineering fields, and conclusion. Let's start the video with introduction to encoding and decoding. So let's know about encoding. It involves converting information from one form to another, often with intent of facilitating storage, transmission, or security. It's about representing data in different formats, often more suitable for particular purpose. For instance, in communication systems, encoding translates information into a format that can be efficiently transmitted over a channel, like converting digital data into modulated analog signals for radio transmission. Whereas in decoding, it is the process of converting encoded data back into its original form or into a form that is understandable or usable. It reverses the encoding process to retrieve the original information. In communication, decoding occurs at the receiving end where the encoded signals are converted back into the original data. So let's know about process of encoding and decoding. Encoding. The first step is input data. It begins with the original data or information that needs to be transmitted, stored or secured. The second step is selection of encoding scheme. Choose an appropriate encoding method or scheme based on the specific requirements of the application. This could be text encoding, compression algorithms, modulated techniques or encrypted algorithms. The third step is transformation. Apply the selected encoding technique to convert the original data into a different format. For instance, there are three steps in transformation process. The first one is text encoding. Translate text characters into binary representation according to specified character encoding scheme. The second is compression. Reduce redundant or repetitive data to minimize storage or transmission space. The third step is modulation. Convert digital data into analog signals suitable for transmission over a communication channel. The fourth step is encryption. Scramble the data using cryptography algorithms to make it unreadable without the appropriate description key. The fourth is output of encoded data. Obtain the encoded data which is now in a free format or structure suitable for transmission, storage or security purpose. Decoding. The first step in decoding is receiving encoded data. Starts with the encoded data that has been transmitted, sorted or secured using an encoding process. The second step is selection of decoding scheme. Choose the corresponding decoding method or scheme that matches the encoding technique used. This is crucial for accurately reversing the encoding process. The third step is reverse transformation. Apply the selected decoding technique to convert the encoded data back into its original format. There are four steps in reverse transformation. The first is text decoding. Interpret binary data into readable text characters based on the specified character encoding. The second is decompression. Expand the compressed data to restore to its original size and structure. The third step is demodulation. Convert received analog signal back into digital data. The fourth is description. Use the appropriate description algorithm and key to unscramble the data and restore its original form. Output of decoded data. Obtain the retrieved information in its original form, identical to the initial data before encoding. So let's know about types of encoding and decoding. The first one is error correcting codes, Hamming codes. These are used for error detection and correction in digital communication. They add redundant bits to data to detect and correct errors. And next is Reed-Solomon codes, widely used in data storage and transmission systems like CDs, DVDs and QR codes for error connection. Then compression encoding, Huffman coding, a method used for lossless data compression by assigning variable length codes to characters with shorter codes for more frequent characters. And then next comes LZW coding, another lossless data compression technique used in formats like GIF, TIFF and Unix compression. The next type of encoding and decoding is modulation techniques which are used in communication. Those are amplitude modulation and frequency modulation. These techniques are used to encode information onto carrier waves in analog communication system. The next is phase shift keying or quadrant amplitude modulation. These are used in digital communication for encoding digital data into analog signals. The fourth step is cryptographic encoding. There are two types of cryptographic encoding. The first one is symmetric encryption. Uses a single key for both encryption and decryption like AES, Advanced Encryption Standard. The next is asymmetric encryption. It involves public and private key pairs such as RSA and that is which is used for secure communication and digital signatures. The fifth type of encoding is image and video encoding. This is Giant Photographic Experts Group, a commonly used method for compressing and encoding digital images. The next is Moving Picture Experts Group. This stands for encoding audio and video data such as MPEG-2 and MPEG-4. The sixth type of encoding is DNA encoding. DNA storage data. This encodes digital data into DNA sequences for long-term storage due to its dense information and storage capabilities. So these are some of the applications of encoding and decoding in mathematics and various engineering fields. The first one is communication systems. Whereas in communication system, wireless communications encode methods like modulation, encoding information into carrier signals for wireless transmission. The next is error detection or correction. Error correcting codes ensure accurate data transmission in noisy communication channels. Examples: Hamming codes, Reed Salmon codes. Next is data compression. Techniques like Huffman coding reduce data size for efficient transmission and storage. The second is information security and cryptography. Whereas in information security and cryptography, there are two types: secure communication, which is used for encryption algorithms, encode data to ensure confidentiality, integrity, and authenticity during transmission. The next is digital signature. Encoding techniques verify the authenticity and integrity of digital documents or messages. Next application is computer science and software engineering. Text encoding. ASCII Unicode encoding for storing characters in computer and programming languages. Serialization and deserialization. Encoding data structures into a format of storage or transmission and then decoding it back for use in applications. Data transmission in networks. Encoding scheme for data transfer protocols like Ethernet, TCP, IP, etc. The next is mathematical modeling and signal processing. Image and signal processing. These encoding methods like Fourier transmission, Welvet transform, and encoding schemes are used for analysis and manipulation. Coding theory. Mathematical methods for designing error correction codes crucial in data transmission and storage. So the summary of this topic is encoding and decoding process are fundamental in information handling across diverse fields. The accuracy and effectiveness of encoding and decoding impact data integrity, security, and efficiency. These processes ensure reliable communication, storage, and manipulation of information across different applications and industries. Thank you for watching the video. Please like, share, and subscribe my video.